Hello friends, we are going to learn concept of mathematical induction from the unit number and algebra of IBDP math AAHL syllabus, and I have taken a problem from IBDP math AAHL past paper. Now the problem here is use mathematical induction to prove that summation r equal to 1 to n r upon r plus 1 factorial equals to 1 minus 1 upon n plus 1 factorial for all integers n greater than and equals to 1. Now the solution: let Pn be the proposition that summation r equals to 1 to n r upon r plus 1 factorial equals to 1 minus 1 upon n plus 1 factorial. Consider P1. Here we are substituting n equals to 1. So the LHS part, here when you substitute n equals to 1, so we will be writing here the value of r would be 1. So it is 1 upon 1 plus 1 factorial equals to 1 upon 2 factorial equals to 1 upon 2. Now RHS, so 1 minus 1 upon 1 plus 1 factorial equals to 1 minus 1 upon 2 factorial equals to 1 minus 1 upon 2 equals to 1 upon 2. So P1 is true. Now assume Pk is true. That is, summation r equals to 1 to k r upon r plus 1 factorial equals to 1 minus 1 upon k plus 1 factorial. Consider p k plus 1. So here n equals to k plus 1, we are substituting. So summation r equals to 1 to k plus 1 r upon r plus 1 equals to 1 minus 1 upon k plus 1 factorial plus, so k plus 1 value we will substitute here, so that is k plus 1 upon k plus 1 plus 1 factorial. Now we will simplify 1 minus 1 upon k plus 1 factorial plus k plus 1 upon k plus 2. Now in second term, if we want k plus 2, for the simplification we will have to multiply by k plus 2 in numerator and denominator. So we will write here 1 minus 1 upon k plus 1 factorial into k plus 2 upon k plus 2 plus k plus 1 upon k plus 2 factorial. We know the property n plus 1 into n factorial equals to n plus 1 factorial. So therefore 1 minus k plus 2 upon k plus 2 into k plus 1 factorial would be k plus 2 factorial plus k plus 1 upon k plus 2. Now we can further simplify, equals to 1 minus k plus 2. Now here the minus sign will come, minus k minus 1 upon factorial k plus 2. Equals to 1 minus, now here k get cancelled and 2 minus 1 would be 1. So this would be k plus 2 factorial. This can be rewrite as 1 minus 1 upon k plus 1 plus 1 factorial. So we can say that p k plus 1 is true whenever pk is true and p1 is true. So pn is true for all integers n greater than and equals to 1. So this is the solution of the given problem. I hope you understood the solution. Please like, share and subscribe this channel.